So every time you walk inside a building, you are trusting something that you can't see. So now we are going to analyze about that thing, that is the soil.
So today let's understand how a soil behaves and its fate of structure.
So now we are going to see about the first analysis, sieve analysis. Firstly, sieve analysis is a process of determining the particle size distribution of a coarse-grained soil. Objective will be explained by her.
The main objective is to find the percentage of particles in a soil sample.
Used to determine the sieve analysis is a set of sieves, a sieve shaker mechanical machine.
First we take a dry soil and weigh them, and then arrange the sieve size in a descending order, and then place the soil sample in the top of the sieve, and then shake the sieve by the sieve shaker for 10 to 15 minutes, and weight the soil written under each sieve.
The next test we are going to see about specific gravity. The specific gravity is defined as the ratio of weight of an soil solids to the equal weight of a volume of water, and the next steps are determined by her. The main objective for this test is to calculate the specific gravity of soil particles. The apparatus used in this test are pygnometer, weighing balance, water and oven. The procedure is, first we have to take the dry soil and weight it, and then add to the pygnometer and add water and then weight it, and repeat this procedure to fill the water finalize. By using the required formula, we calculate the specific gravity of soil particles. The result for this test is the typical value for specific gravity of soil range is between 2.6 to 2.8.
So hello everyone, this is Abraham. So I'll be giving you a brief about the relative density of the soil. So relative density is the measure of how compacted a soil is compared to its densest and loosest possible states. So we do this test by comparing the same soil sample in its densest and loosest state, and also the same sample we will be taking from the site. So according to IS 2720 part 14, to assess the loose state of the soil is poured into the mold with the funnel to assess the Emax value, and to assess the dense state of the soil. So we will pour the soil into the same mold, but we will compact it with a vibrator or a tamping rod to get the minimum void ratio. So it is significant in assessing the safe load bearing capacity and the settlement behavior. It is also critical in liquefaction analysis in seismic zones.
So, from the grain size distribution analysis, the soil is identified as a coarse grain soil with a high percentage of sand and a very little fines. Looking at the grading characteristics, the uniformity coefficient is low and the coefficient of curvature does not meet the standard limits, which means the soil is not well graded. So, according to IS 1498 classification, this soil is classified as poorly graded sand. So this type of soil contains mostly uniform sized particles resulting in high permeability but low shear strength and higher compressibility. To improve its engineering performance, methods like compaction and addition of binding materials are used. Techniques such as vibrocompaction helps to increase density and bearing capacity. Despite its limitations, poorly graded sand is widely used in drainage system, backfilling and sub-base construction when properly compacted. Thank you.